meaning they exist. Okay? There are 2 pairs that come from the cerebrum, 10 from the brain stem. So they are all coming to or coming from areas of our brain. As we look at all of this anatomy, it is an extremely difficult system, to say the least. All right? And there are certain things, certain terms that you're going to come across in patient chart. We're going to have, the brainstem, the medulla oblongata, gotta love that. Look what it does. Heart rate, breathing, swallowing, vomiting. The pons. Information between the cerebrum and the cerebellum. Got a lot of reflex centers there. My midbrain. Ascending, descending, tracks, all right, that we just talked about. The visual reflex center, also part of our auditory. Now, clinical significance. Do you survive damage to your brain stem? No. That's pretty much going to kill you if there's any damage to the brain stem. In the cerebrum, can you survive damage to the cerebrum? Yes. Can it actually be compensated for, like it never occurred? Yes. Which is very interesting. This portion is going to come back to us. This portion we're going to continue because that's going to be higher order thinking. So let's take a peek at this brainstem area. Let's see. This is my primitive portion of the brain. The diencephalon portion, there we go, thalamus, which is going to be coming back to us. The terms that you're going to see associated, like for example, peduncle, the sulcus, the olive, it's really telling you something about the shape of that area. But one of the things I want you to kind of note about this, what do you note about the yellow, which is representing those cranial nerves? You see how they're trying to show all of these cranial nerves that are present? What connection are you making between that? Where is information for the going in and coming out? What part of our brain is it coming from? Which is my primitive portion. These cranial nerves, their reflexes, their information is going to have to go here, and then we're going to have to get it to other areas of the brain, which is kind of cool. So, this primitive portion, all right, is going to have a lot of control over our mechanisms for homeostasis. Not just that, it is controlling information for well, this one kind of goes into some of the other areas. But all of these different things for homeostasis are going to be coming through a lot of these cranial nerves. A major one is the vagus nerve. Ever heard of that one? Just like, Las Vegas. So if we look at this area, the medulla oblongata, the most inferior part, this little portion right here, continuous with the spinal cord. It does have, now this is one of the things that will change. It has both ascending and descending tracts. So information going in, information going out. Here's that nuclei. Discrete nuclei, which were the nerve cell bodies, all right, in the gray matter. Look at what it regulates. Heart rate, blood vessel diameter, respiration, swallowing, vomiting, hiccuping, coughing, sneezing. I thought it was just for whether the alligators were happy or not. That little area, the medulla oblongata. Probably heart rate, blood vessel, respiration. I mean, I don't know about y'all, I kind of like that works, and I don't have to think about it. Just saying. We're going to see in that anatomy, they have what's termed pyramids, just like the term implies, olives, just like the shape of an olive. Pyramids, look what we have. Descending tracts. They're on the anterior surface. Fibers decussate. What does that mean? They cross over. They cross to the opposite side. Therefore, yes, that old saying about the right side of the brain controlling the left of the body, left controlling the right, definitely applies to the medulla oblongata. Olives, all right, this is kind of cool right here. Like I said, they're rounded like an olive. The nuclei that are found there, the nerve cell bodies, they help to regulate balance, coordination, and modulation of sound from the inner ear. The cranial nerves, and you're going to be learning them based on their Roman numerals. You'll get to be familiar with 5, 9 through 11. 9 being one that you're going to see pretty common throughout the entire functioning of this area of the brain. You're going to see it be very common because that's the vagus nerve. Guess what the vagus nerve, as it exits and descends, guess what it innervates? Every organ of the body, which will be really cool. All right, for today, you're going to work on lab 19.